let's go ahead and finish this review sheet up. Remember in part 1, we did numbers 1 through 36. So today we only have 14 problems left to do, okay? That's a pretty quick video, so we'll hopefully get this done quickly, and we'll start with number 39. And here we go. Numbers 39 through 42. The book says to, let me turn over in my book to the right page, find the lengths and angle measures. So, here we go. Let's find the lengths and angle measures. First of all, they want us to find the measure of angle B, okay? The measure of angle B. So here we go. Here's angle B. I'm going to circle angle B, go right across. We'll call this my opposite. Here's my right angle, go straight across. We'll call this my hypotenuse. And this is my adjacent side here. So, notice, students, the two sides that I know are my opposite side and my adjacent side. So the trig function you want to use is not cosine. Cosine has hypotenuse. It's not sine. Sine has hypotenuse. It's tangent, because tangent has opposite and adjacent. So we can say tangent of, now what angle did we circle? B equals, and my pen is messing up, guys, that's why it's hard to write. Hopefully it'll quit doing this. Tangent of angle B equals opposite over adjacent. Remember, TOA. So good, TOA. Alright, now we're looking for an angle, correct? So if we're looking for an angle, then we use the inverse tangent button. So with your calculator, you want to hit inverse tangent. So this pops up, and then I would use parentheses, and I would type in 69 divided by 36, okay? Let me quickly do that with my calculator, and we'll see if we get the correct answer. Hopefully we will. And the answer is 62.4 degrees. And let's see what they have here. 62.4, okay? So I'm going to write that right here after I get rid of this circle. 62, actually I'm going to erase all of this, I believe. And we're going to write 62.4 degrees. Now students, next it says to find the length of AB. The length of AB, this side right here. Okay, well obviously we have a right triangle and we know two sides, so we're definitely going to use Pythagorean's theorem. So here we go. We have a leg of 69. We have a leg of 36. And we have a hypotenuse that we're looking for. 69 squared is going to give you 4,761. 4,761. And 36 squared is going to give you 1,296. Okay, let's add those two together. We get what? 7, 5 carrier 1, 0 carrier 1, 6,057. I think that's right. I did that in my head. I hope that's correct. Now we'll take the square root of both sides, and I'm getting 77.82. So 77.8 equals my hypotenuse. Alright, very good. Now, moving on to the sine of A. Now students, would you please listen to me? I know all of the sides of this right triangle now, okay? So when I ask you to find the sine of angle A, there's two ways to do it. On a test or a quiz, you could actually check your answer, okay? For example, I know this is 62.4, so that tells me that this has to be 27.6, okay? Because this plus this plus this is 180. Now, if I want to find the sine of A, I could just type into my calculator the sine of what? 27.6. And if you do that, you will get 0.4633. Now, I would like to show you another way you could do this. Another way to find the sine of A would be opposite over hypotenuse. So 36 over 77.8. So take your calculator and type in 36 divided by 77.8, and guess what you'll get? 0.4627. You're off by about 1/1000th, okay? But definitely close enough. And so either way, either one of those two ways would work, okay? Alright, now they want you to find the tangent of B. The tangent of B, well students, first of all, B is 62.4. So you're welcome to simply take the tangent of 62.4, okay? And if you do that, you're going to get 1.9128. But another way to do it would be this. Tangent is opposite over adjacent. So you could also just take 69 divided by 36, okay? Because if you're trying to find the tangent of angle B, then you would circle angle B. This would be your opposite side. This would be your adjacent. So the tangent of B would be opposite 69 divided by 36. And you would get the exact same thing, 1.9166. So 1.9167. So you can see they're only off by about 4/1000th of a point. Okay? Alright. So any of those, either one of those two ways is acceptable. Okay? Alright. Let's go ahead and continue on to numbers. Number 43. This is a really great thinking problem. A regular hexagon is divided into 6 equilateral triangles. Now let's stop right there. If they're equilateral, if all of these triangles are equilateral, don't forget that also means they're equiangular. So I know for sure this angle is 60, this angle is 60, and this angle is 60, okay? So off to the side I'm going to draw a little bigger triangle, alright? What is the perimeter of the hexagon? So don't forget that. We're trying to find the perimeter of the hexagon, okay? So there it is. Alright, now let's find the perimeter. Here's a bigger triangle here. I'm going to draw it just like this triangle here. Okay, so we have 60, 60, 60. Now students, would you please think about this? If I can find this length right here, then I can easily find the perimeter, because it said it's a regular hexagon. I believe it said regular. Let's see. It is, yeah, regular hexagon. So if it's a regular hexagon, I know all of the sides are the same. So really, all I have to do is find this length here. And let's just pretend this length is 8. Well, if this is 8, this is 8, this is 8. They're all 8 all the way around. So 8 times 6 is 48. It's really easy to find the perimeter, students, if I can just find this length right here. Okay, so here's what we're going to do. Notice they tell me the altitude is 6. See this altitude right here? So if I draw an altitude in this triangle here, it's going to be 6. And we learned this a long time ago. Anytime you draw an altitude in an equilateral triangle, it divides the angle in half. So this is 30, this is a right angle, and this height here is 6. Now, students, please listen carefully. Notice I have a 30, 60, 90 triangle. Do you see that? So I can very easily find this length right here, because I know one length right here. It's 6, okay? So watch what I'm going to do. I'm going to label my sides with a different color, okay? Notice this is 60. Alright, in fact, I think it'd be really wise just to get rid of this half of the triangle right over here. We just do not need this half at all. We now have established the fact that we have a 30, 60, 90 triangle, okay? So, this is 60, go straight across. This is 6, so this is my longer leg, okay? This is 30, which is smaller than 60, so 30 is the smaller angle. So when I go straight across from 30, this is my shorter leg, okay? Remember, the longer leg is across from 60. The shorter leg is across from 30, and of course this side over here is my hypotenuse. Now, what did we learn, students? Let's think about our special triangles. And listen, if you don't have these memorized, you better memorize them for the test, okay? I'm telling you, you've got to know these for the test, okay? We know the hypotenuse in a 30, 60, 90 triangle. The hypotenuse is twice as big as the shorter leg, or you can say the shorter leg is half as long as the hypotenuse. We know that you can take the shorter leg and multiply it by the square root of 3, and that will give you the longer leg, okay? okay? So, if I can find the shorter leg right here, that would give me the distance from here to here, okay? There's my 30, 60, 90 triangle right there in black. Okay, so I can find the shorter leg. How do you find the shorter leg in a 30, 60, 90 triangle? You take the longer leg and divide it by the square root of 3. So 6 is my longer leg. So I take 6 divided by the square root of 3. Of course, you never want a radical in the denominator, so you multiply the top and the bottom by the square root of 3. If you do that correctly, you will get 6 square root of 3 over square root of 3 times square root of 3 is 3. You can reduce your outside numbers by 3, so you're left with 2 square root of 3. Got it? So from here to here is 2 square root of 3, and from here to here is 2 square root of 3. Okay? So if you add those together, 2 square root of 3 plus 2 square root of 3, you will get 4 square root of 3. Now, if you don't see where I got that, look at it like this. Instead of taking 2 square root of 3 plus 2 square root of 3, just take 2 square root of 3 times what? Times 2. So 2 times 2 is 4. 4 square root of 3. So this whole side here is 4 square root of 3. Got it? Now, how many sides are there? 1, 2, 3, 4, 5, 6. So simply take 4 square root of 3 times 6, and that would give you 24 square root of 3, and that would be the perimeter, okay? 24 square root of 3. Pretty good problem. If it's a little fuzzy, back it up and watch it again, okay? Really good problem. Alright, number 44. A regular octagon is divided into 8 congruent triangles. That means all of these triangles are congruent. Each side of the octagon is 4 inches. How long is the altitude? Okay, let's take our time here, students, okay? First of all, understand, if we have a regular octagon, that means all of these angles here are congruent, and all of the sides are congruent, okay? Number 2, if all of these triangles are congruent, which it says right here, this regular octagon is divided into 8 congruent triangles, then I can definitely assume, I can definitely know for sure, this is the center of the octagon. So that means all of these spokes, if you will, like spokes in a wheel, all of these lines here have to be congruent. They have to be. Plus, we know they're congruent triangles anyway, so they have to be congruent. So we know this side here is congruent to this side here, okay? So if I could, students, I'm going to slide this picture out of the way, or this problem up in a second before I do. Let's look at what we're going to do. They want us to find how long the altitude is right here, okay? So I'm going to create some space here, and don't lose sight of the trees for the forest here. We're trying to find how long A is, okay? So all we really need as students is this triangle at the bottom right here. Now, what I'm going to do is I'm going to redraw this triangle here so we can work with it, only much bigger. Okay, there we go. And we already established the fact that this side here is congruent to this side here. We already said that, okay? Now, if that's true, students, then we know this angle here has to be congruent to this angle here. Remember, we learned that when 2 sides of a triangle are congruent, then their opposite angles are congruent. Okay, we learned that a long time ago. So now I know these angles are congruent. Now, if I drop an altitude down right here like this, so that I have a right angle right here, look what I have, students, please. I have, if this is a right angle here, this is a right angle here, correct? So I have angle, angle, side, congruent to angle, angle, side. So I know these 2 triangles are congruent because they share a side. So I know this side here. I know this side here has to be congruent to this side here, okay? And I know the angles are congruent because, like I said, we know that this angle here is congruent to this angle here. So I have angle, angle, side, congruent to angle, angle, side, which means, students, these 2 triangles are congruent. Now, if these two triangles are congruent, then that means all of their parts are congruent. So I can now state that this side here is congruent to this side here. Why is that important? Because look, students, this whole length is how much? 4. Which means this whole length is how much? 4. But if I cut it perfectly in half, now I know I have a 2 here and a 2 here. Okay? So if I know that, then it's really not going to be too difficult to find the altitude here. Alright? Now, students, one more thing I have to establish. Please watch this carefully. I can find this length right here. We'll call it A for altitude, because the book has called it A also. I can find this pretty easily, but I'm going to first of all get rid of this part of the triangle here. I just don't need it anymore, okay? It's going to do nothing but just get in the way. So I really don't need that. Alright, now, I'm really looking good to find this length, but I need to know this angle real quick. Now hold on, guys, think about that, please. Think about that. We know we have an octagon, right? So we know all of these angles are congruent. Well, let's find out, what are all these angles added together? Remember, we have a formula that tells us the sum of all of the interior angles of a polygon, where the n is, you put an 8. 8 minus 2 is 6, so we have 180 times 6. That's 1080. So if I add up all 8 of these angles right here on the inside, all 8 of these angles, I get 1080. So I'm going to divide that by 8 to find out what one angle is, okay? So divide that by 8. I get 1, 28, 3, 24, 40, 135. So please watch carefully, students. This whole angle from here to here is 135. That means this whole angle here is 135, okay? Now, if the guys can think about this, please. If all of these triangles are congruent, which is said all these triangles are congruent, that means this angle here is congruent to this angle here, and this angle here is congruent to this angle here. So if this whole angle here is 130, by the way, let me stop and say this. You're like, Mr. Earhart, I'm getting this, but I wouldn't have thought of it on my own. Guys, that's why I'm the teacher, okay? I'm not asking you, what have you thought of this on your own? I'm asking you, do you understand what I'm saying? And if you understand what I'm saying, then you're on the right path to doing these on your own eventually, okay? And hopefully in time for the test. But what I'm saying is this whole angle is 135. So divide that in half and you get 67.5. So this angle right here has to be 67.5. Has to be this angle right here. I'm going to change colors. This angle right here from here to here has to be 67.5. So now I'm so ready to solve for A. Here's the angle that I know, so I'm going to circle it. Go straight across. This is your what angle? What side? Opposite. This is your hypotenuse side. This is your adjacent side. You know this side here, and you're looking for this side here. So the two sides that you want to use would be opposite and adjacent. Once again, because you're looking for this side here, and you know this side here. So I'm going to use tangent. Tangent of 67.5 equals opposite, which is A, over adjacent, which is 2. Now, the tangent of 67.5 is nothing more than a number, and it's going to be 2.4142. Now, your denominator of the fraction is 2, so we're going to multiply both sides by 2. If you multiply this side by 2, you will get 4.8284. And if you multiply this side by 2, you're left with A. Alright, so there is the height of the triangle. 4.8284. They have 4.83, which is the exact same answer. Another good thinking problem. Alright, okay, moving on to 45. Road salt is stored in a cone-shaped pile. The base of the cone has a circumference of 75 feet. Now please listen to me carefully and I will explain that. That means the distance around this circle. Circumference means the distance around the circle is 75 feet. The cone rises at an angle of 50 degrees, so this angle right here is 50 degrees. What is the height h of the cone? Now, I want you guys to think about this, please. Here's a right triangle, look right here. This is my H, this is my S, this is my R, and this is my 50 degrees right here. Okay, now I'm going to pull this out of the way just for a second. And pull this back up again. So, what I did, students, is I took this triangle right here and I cut it out and I put it right over here. Now, they're asking us to find the height, right? Now that would be so easy, guys, if we just knew one of these sides. Man, I wish we did. Well, actually, we don't, but we can find it real quick. Because don't forget, we know the circumference is 75, and they give you a little hint right here. Circumference is 2 pi r. So let's think about that. If circumference equals 2 pi r, and what's the circumference? 75. So what can I put for C right here? 75 equals 2 pi r. Hey, I can find what r is very easily. Divide both sides by what? 2 pi. So with my calculator, I'm going to take 75, I'm going to divide it by 2 and hit enter. Then I'm going to divide it by 3.14 and hit enter. And if you take 75 and divide it by 2 pi, you will get 11.943. 11.943. So now I know what r equals. 11.943. Now I can find the height very quickly because I have an angle. Circle that angle, go straight across. We'll call this what? Opposite. This is my right angle. This is my hypotenuse over here. Hypotenuse. And this is my adjacent side. So I'm looking for the height. So I want to use this side. I know the length of r, so I'm going to use this side. So I'm using opposite and adjacent. That's going to be tangent. So I'm going to use tangent. Tangent of angle what? 50 equals opposite over adjacent. Now the tangent of 50 is just a number. That's what the tangent of 50 is. 1.1918. Now if I multiply both sides by the denominator, and the denominator is 11.943, if I multiply the left side by 11.943, I'm going to get 14.23. If I multiply the right side by 11.943, I will get h. So the height is 14.23. Alright? Alright. Moving on to number 46. Now, they want us to find the length of S. Well, students, we just found h. We just found it. 14.23. So I can use Pythagorean's theorem, can I not? We also just found r. R is 11.943. So I have one leg, which is 14.23 squared plus 11.943 squared equals hypotenuse squared. Now to save time, students, I'm going to type this whole thing in my calculator. So 14.23 squared plus 11.943 squared. So 14.23 squared plus 11.943 squared equals this right here. I'm getting a big number, 300. And you don't have to write all these decimals out. I'm going to, just to make sure I'm being accurate. You probably don't need to. I'm getting that. And now take the square root of both sides. And you're going to get 18.57. I'm going to put 18.6 equals s squared, or s. So students, look, as soon as I realized I knew two sides of the right triangle, it's very easy to get the third side by using Pythagorean's theorem. Okay, it really, really is. does. Okay, moving on now to numbers 12 and 13, I believe. Okay, the directions say to find the angle measures of the right triangle PQR. So I have a right triangle PQR. Now I will say this, I'm not sure which one of these is the longest, okay? Well, actually I do know, because if you have two sides that are the same, 5 and 5, then this has to be the longest side, because a hypotenuse, if this was the hypotenuse here, it could never equal one of the legs. That's impossible. The hypotenuse has to be the longest side. So I know square root of 50 is the longest side, plus the square root of 50 is 7.07, so QR is my longest side, okay? So you can put your Q here and your R here, or your R here and your Q here, it doesn't matter. I'm going to put my Q here and my R here, put my right angle here, and label this square root of 50. So right away, my longest side is my hypotenuse. Now put your P right here, okay? Now they want us to find the angles, I believe. Let me look at the directions again. Yes, find the angles of this triangle. This is 5 and this is 5. Now students, I'm going to be honest with you. We're done. We're finished. This is so easy. Listen, anytime two sides of a triangle are congruent, 5 and 5, then their opposite angles are congruent. So this angle here has to be congruent to this angle here. So I know right away both those angles have to be 45 and 45, because 45 plus 45 is 90, plus 90 is 180. It's that easy. We're done. Okay, there's really no sine, cosine, or tangent involved in this problem here. Okay? Alright, moving on to number 13. Now listen, I'm pretty sure QR is my longest side, but we know 1/2 is 0.5. We know 1/4 is 0.25. Let me take the square root of 3 real quick. Divided by 4, and you'll get, actually I'm wrong, you get 0.4. Let's see, the square root of 3 divided by 4, you get 0.43. So 1/2 is your longest side. Okay, 1/2 is your longest side. So when I draw my right triangle, PQ will be my hypotenuse, PQ, and this is R. So PQ is 1/2, QR is square root of 3 over 4, and PR is 1/4, okay? Now let's find the angles, okay? Well, here we go. First of all, choose which angle you're going to solve for first. Students, it does not matter which angle you choose first. I'm going to choose P just because I feel like it. There's no other reason. So I circle P. This is my opposite side. This is my hypotenuse. This is my adjacent, okay? In order to find angle P, I don't really want to use the square root. That's going to be a mess. I would rather use 1/2 and 1/4. That's just my opinion. You are more than welcome, students, to use this side here. Okay, that's fine. I'm not going to. It's got a square root. It's going to be a little messy, so I'm not going to use this side. I'm going to use these two sides here, okay? So I'm using adjacent and hypotenuse. Now think of your functions. So, TOA. Which one has adjacent and hypotenuse? Cosine does, okay? So I'm going to use cosine, and I'm going to say cosine of angle P, okay? So cosine of angle P, cosine of angle P equals adjacent over hypotenuse. Okay, now before you type this in your calculator, let's make this a little easier, okay? You can say the cosine of P equals 0.25 over 0.5, okay? And then divide that out with your calculator. So 0.25 divided by 0.5 gives you 0.5. So you really have the cosine of P equals 0.5. Now we're ready to use our calculators, okay? So am I looking for an angle? Yes, I am. So I want to hit inverse cosine of 0.5. Inverse cosine of 0.5. And if you type that in correctly, you're going to get 60 degrees. So P is 60. So if this is 60, then Q is 30. And just like that, we're finished, okay? So really, those are not too difficult, all right? Okay, moving on to number 16. One leg of a right triangle is 12 feet. The angle opposite this leg is 25 degrees. How long is the other leg? So, here's my right triangle. I'm not really worried about drawing it to scale. That's not a big deal. One leg is 12 feet, so this is a leg. We'll call it 12 feet. The angle opposite this, so go straight across, is 25 degrees. How long is the other leg? So we'll call this x, okay? Alright, so we're looking for x, or in other words, the other leg. Remember, this is not a leg right here. This is your hypotenuse right here, okay? So we're looking for the other leg. Well, we know that we can use 25 degrees. So we circle that. We go straight across. This is opposite. This is hypotenuse over here. So this is adjacent. So the two sides I'm dealing with are opposite and adjacent. And we know that's going to be tangent. So the tangent of what angle did I circle? 25 degrees equals opposite over adjacent. Alright? Now, we know that tangent of 25 is just a number. So the tangent of 25 is 0.4663. Alright? 0.4663 equals 12 over x. Now, whatever your denominator is, in this case, it is x. Whatever your denominator is, you multiply both sides by the denominator to get rid of your fraction. So, I'm going to multiply 0.4663 by x. I'm going to multiply the right side by x, which will leave me with just 12. And now, students, just take 12 and divide it by 0.4663, and you'll have the correct answer. Alright? And what you should get is 25.73. 25.73 is the measure of this side right here. Alright? 25.73. Alright, let's continue on number 17. Alright. In a right triangle, ABC, the hypotenuse has a length of 6 centimeters. Given that side A is 4 centimeters, solve the entire triangle. So, we have a right triangle. And we are told the hypotenuse is 6. Now, obviously, A cannot be here, okay? And here's why. Listen to me, if this is angle A, then this over here is side what? Little a. So little a would equal what? 6. But we're told here little a equals 4. So I don't care where you put a, just don't put it here. Let's put it up here, okay? You're welcome to put it down here if you want to, and you'll still get the same answer. It doesn't matter. So a, and I guess we'll put a b here, and a c here, and little a is right here, and little a equals 4. Now they want us to solve this right triangle, okay? Well, first of all, find the easy side first, or find the easy part first. If we know two sides, we can very quickly find the third side by using Pythagorean's theorem. So we have a leg squared plus a leg squared equals a hypotenuse squared. So now I have leg squared plus 16 equals 36. Bring the 16 over and make it a negative 16, and I'm left with leg squared equals 20. Now I take the square root of both sides. The square root of L squared would be L, and the square root of 20 would be 4.47 or 4.5. So L equals 4.5. Okay, so put that right here, 4.5. So there's one answer. Now, students, I do not care if you solve for angle A or C. That is totally up to you. I'm going to go with A. So I circle A. That makes this my opposite. This is my hypotenuse, and this is my adjacent. Now, students, listen to me. You are so more than welcome to use this side here when you solve for angle A. However, I'm not going to. First of all, this is not an exact number. You had to round it from your calculator. Secondly, these numbers here don't have any decimals. They're nice whole numbers. So I'm going to use opposite and hypotenuse. That's what I'm going to do. So when I solve for angle A, I'm going to use these two sides. Now, which trig function has opposite and hypotenuse? Sine does. The sine of angle what? opposite over hypotenuse 4 over 6. So now, are we looking for an angle? Yes, we are. So we hit inverse sine of what? 4/6 and hit enter. Let me grab my calculator here. Inverse sine 4 divided by 6, enter. 41.81. I'm just going to put 42 degrees to make it a little easier. So if this is 42 degrees here, then this over here has to be, let's see, 50, 48, this is 42. This has to be 48 degrees here. Okay, so let's see how correct we were. We claimed that this side here was 4.5 and they have 4.47. One angle is 41 degrees and the other angle is, well, we know this is a right angle and they called their right angle C. I called it B. That's no big deal. One side we looked for 4.47, 4.5. Another angle is 41.8. I put 42. Their other angle is 48.1. I put 48. Okay, so all of this is correct. Okay, number 18. Given that S equals 2, what is Y? Now, this is going to be a decently challenging problem, so I need you to really listen carefully. If you've ever worked at all with cars or any type of tools where you're dealing with, and if you'll read the problem, it says you have a hexagonal nut, okay? Now, that does not mean that the polygon is crazy, okay? That's a nut, okay? That's not what it means. It's a nut that you can use a ratchet set on to tighten or loosen. If it's a nut, if it's a regular nut, it does mean that all these sides are going to be the same. Now, maybe some of you ladies would not know that. Maybe some of you men did not. But guys, anytime you're dealing with nuts and bolts and all of that, it is totally understood that all of these sides are the same, okay? They totally are. So what I have is this. You're told that S equals 2 right here, okay? And you're looking for Y, which is this total distance here. Now the directions tell us that we have a hexagonal nut, which means I have 6 sides, okay? All of these angles will also be congruent, okay? If it's a nut, it's going to be a regular hexagon, okay? So all of these angles here are congruent. Now, in a hexagon, if you used 180 and minus 2, you would get 720. That means all of these degrees here are 720 degrees. Got it? I think that's right. Let me make sure real quick. 720. Okay. Now, sorry guys, I paused the video. That did not make sense at all. Of course that's incorrect, and I should be fired as a geometry teacher. All of the angles added together are 720. So if you take all 6 of these angles, my goodness, how could one angle be 720 degrees? Wow. All of these angles added together are 720. If you use this formula here and put a 6 right here, you'll get 720. So if all 6 angles are 720, divide that by 6 and you'll get 120. So each of these angles here are 120 degrees. Got it? Now, when you take this line here and cut it right down the middle to the middle of the hexagon like this, it's obviously going to cut that angle in half. So if this whole angle is 120, then these little angles here are 60. So that's 60 and that's 60. So this has to be 60 also. Okay? So with that in mind, now here's what I want to show you, okay? Please watch this, students, carefully. If I can find the length of this altitude right here, would that not be half of Y over here? Sure it would. And then I could multiply it by 2, which would double it, and that would be this length here, okay? So what I'm trying to show you is this. If I were to, let me show it to you like this. If I were to take a pencil and very carefully trace over this right here, watch. Starting here and going like this. And now grab that line and put it right here. Booyah, it's perfect. Y is the exact same length going up and down. So my goal, in my opinion, my goal is to take this triangle here, find this altitude here, then multiply it by 2, and I'll have this whole length of y right here. So I think it's very helpful to draw the triangle off to the side. So here's my 60, 60, 60 triangle, okay? Now, if I draw an altitude straight down like this, that's going to give me what right here? 30. This whole length from here to here is 2. So from here to here is 1, okay? Now, I don't need the rest of this triangle. Now let's see, here's 60, go straight across, this is my longer leg. Here's 30, go straight across, this is my shorter leg. This is my hypotenuse here. Remember, we know all kinds of shortcuts when you're dealing with a 30, 60, 90 triangle. Now this is the side right here that I want to find the length of, my longer leg, which is this length here. And then once I find that length, I'll multiply it by 2, and that'll give me the entire length, which is what will equal y. So I'm going to find this length right here. So here we go. Let's see, what I learned in my notes is the longer leg equals, you can take the shorter leg and multiply it by the square root of 3. That's what we learned. So your shorter leg is 1. 1 times the square root of 3 is just square root of 3. So there we go. So the longer leg equals square root of 3. So from here to here I have square root of 3. So from here to here is square root of 3. So multiply that by 2 and you'll have the entire length. So square root of 3 times 2 would give me 2 square root of 3, which is the correct answer. I'm looking in the book now to make sure that's correct. And yes, that is the correct answer, 2 square root of 3. Okay, alright, number 19. Now, x equals 2, so they're telling us this entire length right here is 2. What is s? Alright, now, students, if this whole length here is x equals 2, so if this whole length is 2, that means this whole length right here is what? 2, correct? However, if I can put a point here in the middle and draw a line like this, I know now that if the whole length is 2, then from here to here, this length has to be how big? 1, okay? And I already established the fact earlier by using my 180 and minus 2 that each of these angles is 120. So when you cut it in half at 60, I already showed you that in the last problem. So I know I have a 60, 60, 60 triangle. So here's my triangle. Looks something like this. Okay, I know this side here has a length of 1. I know this is 60. I know this is 60 here, okay? Now I'm trying to find the length of s. Okay, so here's what I'm going to do. I'm going to draw an altitude, okay? I'm going to draw an altitude and call this 30 degrees. Alright, now, here's 60. This is my longer leg. Here's 30. This is my shorter leg. This is my hypotenuse. Now we're trying to find the length of s. S is right here. So I've drawn my triangle like this. So really what I have right here, my shorter leg, is half of s. S goes from here all the way to here. But this segment right here is this segment from here to here. Well guys, this is so easy. We learned when we studied 30, 60, 90 triangles that the hypotenuse is twice as big as the shorter leg, or you can say the shorter leg is half as big as the hypotenuse. So if the hypotenuse is 1, then the shorter leg is half of that. It's 0.5. So if from here to here is 0.5, then multiply that by 2 to give you the whole length all the way across, and 0.5 times 2 is 1. Okay, so the answer is 1 for s, and I just looked in the book and that is the correct answer, 1. Okay, so students, I hope that this video has been a help to you. If you have any questions, don't hesitate to call or email.